Hello, I'd like to welcome you to our digital classroom. I'm Jerry Winslet, along with...
Kenneth Ezo.
Yeah, there you go. I was going to say it for you, but it's all right.
All right.
We're good. But today, this is going to be the first of a few different shows that we're going to be doing for you for the next few different months. So I hope you enjoy it. Today is on the residential electric water heater. And we're going to talk a little bit about the water heater, how it works. We're going to talk some sequence of operation. Then we're going to get into some troubleshooting and some installation tips. We'll cover that as well, and some troubleshooting and some service work on it. But before we begin, I just want to let you know if you have questions during the show, you don't have to wait till the end of the show to ask them. You can use the chat feature, which is on the right-hand side of your screen. Just ask the question, and we'll get to it. We're going to try to have a question and answer session at the end of the show and get to as many as we can. So we've got a lot to do today.
A lot to cover.
Yes, we do. So we need to go ahead and get busy. All right, electric water heater. First off, I mean, we all pretty familiar with electric water heaters, and obviously we really want to talk about service, but let's kind of go over how electric water heater works first, and what's the advantage of an electric water heater, because we make hot water at this company. And we have many different types of water heaters, from gas to tankless and even heat pump water heaters. But electric water heaters, it's a very proven technology. I mean, it works. So let's talk about the advantage of having an electric water heater and why somebody would go with electric water heaters.
Electric water heaters have been around a long time. They are one of our most simple water heaters to actually service. Mm-hmm. They have 4 parts to make them work: 2 elements, 2 thermostats.
Okay.
The elements are pretty much kind of like a light bulb in a way. They're about as difficult as a light bulb to figure out.
We've got an element right here. Now this is a 4,500 watt heating element?
Yeah, it's a 240 volt, 4,500 watt heating element. This is actually a dual rated heating element.
Okay.
It will also work at 208 volts and heat at 3,500 watts.
Right.
And then you have 2 elements and you have 2 thermostats,
okay,
upper and a lower. The thermostats work kind of like switches. That's all they do. They tell the heating element when it needs to turn on or when it needs to turn off.
So we've got a shot of the thermostats up there. We were showing that. And that's basically your light switch. That's going to turn on the light bulb, which is going to be our heating element in this case.
Pretty much.
Okay, so that's the 4 parts on the water heater. So, when it comes to service, really we're only really concerned with those 4 parts, just to make sure that they're working or not working in some cases.
Yeah, and they're fairly easy to diagnose to see if something's going on with them.
Okay, and typically, they do replace and place jobs. We're pulling out an old electric water heater. Most people usually go with the same thing they had before, so they put that electric back in there. Because we have so many different types of water heaters to choose from, they may not have gas in their area. But with an electric water heater, we can put that in places we can't put the gas.
Yeah, pretty much in an electric water heater, you can install it anywhere in the home. It's an electric water heater, so that it doesn't require air because it doesn't have combustion. So that's a great thing about it. They're fairly simple to hook up. The sizes really, until recently, haven't really changed very much. NECA 3, they've become a little bit bigger, but that happens. They've also, have a lot more insulation, which is a good thing. They're a lot more energy efficient.
Yeah, and we actually have one over here we're going to be talking about working on, and it's got so much insulation that we had to kind of cut some of it out so you could actually see what we're doing for camera purposes. When we open up the lower panel, when you get a new water heater, it's not going to look like what ours looks like, but for our purposes, so you can see it, it's going to be kind of wide open in there. All right, so now I want to go ahead. We're going to go over to a water heater, and we're going to talk a little bit about installation and then get into troubleshooting. So come with me. Bring your water. You probably want to get something to drink. All right, so we're talking about an electric water heater, installation of an electric water heater, and it doesn't look like there's much to it. I mean, we've got electricity run to it and your water lines. But like with gas, you've got to worry about, gas and venting. With this, it's pretty much plug and play, isn't it?
Yeah, it's pretty much plug and play. Pretty much for an electric water heater, you have 2 water connections, right? You have a cold water pipe coming to it and a hot water pipe coming to it. You have an electrical connection typically coming from your fuse box, or an electrical disconnect if you're not line of sight of your fuse box. And then usually you might either have a opening or a drain, like the TMP valve's going to
Right.
be plumbed to a drain, or it may be plumbed to a drain pan that's plumbed to a drain. And so, I mean, it's not really that connections. It's one of the easiest, fastest water heaters to install because they're simple.
Right. And you're talking about plugging electricity into it. Do we use like a three-prong plug? I mean, does this go into a wall outlet, or are we talking all of them are, you know, hardwired?
Yeah, typically they're all hardwired directly from the fuse box. In some cases, it kind of depends on where you live, what codes may allow. I've seen anything from, in the past, anything from Romex, just being wired right to the junction box. We have a piece of seal-tight that's a watertight connection that keeps water out of it, you know, that runs to a disconnect. But it just really depends on local codes. But it's not typically something you see plugged into an outlet because you would have to have a outlet capable of handling at least about 30 amps.
Okay, so 30 amps is what we're looking for on typical water heaters. Okay, and now a little bit more about this installation. If you're looking at it, you know, we've got our water lines. One thing I've noticed is we've got a thermostatic mixing valve on this one. I know we're using this one for show, but this is a whole house mixing valve. Now, does that help with, and this doesn't have anything really to do with electric water heaters, but with water heaters in general, and because it's right here, you may have questions about it. What kind of advantage does a thermostatic mixing valve give the water heater and the customer?
Well, you have several advantages to a thermostatic mixing valve. One is it prevents scalding. We've recently had some codes go through ASSE 1070 saying that the thermostat shouldn't be the only temperature limiting device on the water heater.
Right.
Stuff can go wrong, elements could ground, which we'll talk about later, thermostats could stick, and that could potentially cause you to be burned because the water is going to become scalding. So with a mixing valve, it'll prevent that because it'll pre-mix the water till we only have, say in this case, 120 degree water coming out no matter how hot the tank is.
Right.
Another advantage of a mixing valve is this. You can increase the temperature of the water heater and pretty much make your water heater feel bigger. In some cases, about 30% bigger. And so you could get a lot more hot water because you would draw less hot water off the tank because the storage temperature is so high, and use more cold water to get the temperature you typically take a shower with. And so it can make a smaller water heater feel bigger.
Yeah, that's a great advantage because you'd use less hot water.
Yes.
Because the water is a lot hotter, they'll use less of that and add more cold water to mix it down. So that's a great feature. Now, we actually recommend is point of use mixing valves at each point of use, you know, each hot water faucet. This is an example of a whole house mixing valve.
Correct.
Another thing on this installation, we have a thermal expansion tank, and we can't talk about installation without thermal expansion tanks. We recommend them. They're highly recommended because especially on a closed water system.
Yeah, really, actually, if you read the manual, the warranty with the water heater, if you're on a closed water system, for the warranty to apply, you have to have a properly installed, properly pre-charged expansion tank, which is very important.
Yes.
A lot of people install them, but they don't pre-charge
Yeah,
them.
that's my next thing. That's one of the biggest mistakes that somebody will make, especially DIYers. They'll install the thermal expansion tank, think they're doing well. You know, I did it all right, and end up having the same problem, still having thermal expansion because they didn't pre-charge the thermal expansion tank with air. And let's talk about that. How would we do that the correct way?
Well, the correct way to charge an expansion tank, and this is very important, you have to check your water pressure first.
Right.
You want to check your water pressure. We typically recommend over a 24-hour period. And I have an example of a water pressure gauge. I have a water pressure gauge right here. This one has a lazy hand. And why that's important is this. Your water pressure typically is going to fluctuate some. And so the way this works, you have a black hand that turns up the dial, and it carries the red hand along with it. But what happens is the black hand gives you your actual static pressure, your current water pressure right then. But at its highest point, it's going to carry the red hand along with it. And even if the black hand drops, the red hand's going to stay where it is.
So it's going to show us our highest pressure.
It's going to show the highest pressure, which is very important. And the reason why that's very important is this. Typically, this is not something that's strictly enforced at the time. typically water pressure should never exceed about 80 psi.
Okay.
We actually recommend in a house, a residential home, for your water pressure to be somewhere between 50 and 60 psi.
Okay.
If your water pressure exceeds 80 psi, we typically recommend that you install a pressure reducing valve, which lowers the water pressure, and set it somewhere between 50 and 60 psi.
Okay, and that'll hold that pressure steady.
Yes.
Okay.
Which will cause your tank to live longer, to cause your toilet valves and your
Yeah.
ice makers and all this plumbing stuff in your home to last longer. But that's just typically what we recommend.
Okay, and then we're going to set our pressure on our thermal expansion tank to whatever pressure our incoming water pressure is, right?
Correct. Say we have 53 psi of water pressure.
Right.
It stays at 53 all the time. It's 53. Before we ever install the thermal expansion tank on the cold water line, we'd fill it full of 53 psi of air. It needs to match exactly what your water pressure is. Because if it doesn't, say you don't have enough air in it, or in the instance you have too much air in it, it's going to act like you don't even have a thermal
Yeah, it's not doing
expansion
anything
tank.
at all.
Yeah. Yeah, not enough air. It's just going to press the bladder all the way to the top and not give you anywhere to absorb that additional volume of water. Or if the too much air in it, it's not even going to move the bladder.
Okay.
And so it's very important that you properly install the expansion tank.
Yeah, so you got to do all of this before you install it. Before we put it on our water line, we're going to pre-charge that the air into our thermal expansion tank, and then we're going to go ahead and put it on so it can work properly. So it's just a couple things that we want to keep in mind. Whenever you're working on water heaters out in the field, you might want to check the pressure of the thermal expansion tank if they're experiencing thermal expansion because it may have not been installed correctly. Okay, so let's go ahead and get with this water heater. Let's talk about, that's a little bit about the install of an electric water heater. Now, how the water heater works. Let's go ahead and talk about that. And let's talk a little bit of the sequence of operation, how this water heater works and how power flows through this water heater.
All right, the way a typical electric water heater works is this. You install the water heater, you have a complete cold tank of water. The upper element and upper thermostat comes on first. So the upper thermostat powers the upper element.
Okay.
All right, and then once it satisfies this top 20% of the tank for temperature, the thermostat transfers power down to the bottom thermostat, which powers the lower element, and it heats the other 80% of the tank.
Okay, so that's on a cold tank of water.
A cold tank of water.
So you've got a cold tank just installed. The first thing that's going to happen is this upper thermostat and heating element are going to energize, going to heat up the top 20% until that thermostat satisfies.
Correct.
Whatever temperature you have set for, which is 120 is what we recommend.
Yeah, they're factory preset at 120.
Then we're going to throw power down to the lower thermostat and heating element, and it's going to heat the rest of the tank up until it comes up to temperature, and then the unit will go into standby.
Correct.
Now the water heater's hot. Now, what happens when they start drawing water off a hot tank?
Well, say I have a hot tank of water sitting there ready for me to use, and I go to take a shower. All right, cold water is going to enter the tank through the cold water connection. It's going to enter through the dip tube and dump into the bottom of the heater.
Okay.
And cold water is going to push the hot water out. Well, if you think about that, the cold water is going to come in and dump to the bottom. That's going to cool the lower portion of the tank, which is going to cause the lower thermostat to power the lower element, and it's going to come on.
Okay.
And then, you take a shower, you're going to use several gallons of hot water, but unless you drain this water here completely of hot water, the upper element thermostat may never power back up to kick on.
Okay.
Usually, your lower element and lower thermostat are the workhorse, and they heat most of the water.
Yeah, and if anything was to fail, usually first it's that lower element, correct?
Yes, just like with anything, if you have a part that works a lot, usually the part that works the most is typically the one that's going to fail the most because of usage.
Yeah, and I want to kind of go back to the cold tank. I mean, that's how the water heater operates. But when we were talking about installation, because that's what we were first talking about, one thing that we get, and we have a call center here, we take a lot of calls, and we know what's going on in the field with people out in the field installing these, either DIYers or contractors installing these. One thing that we see a lot is on a cold tank is what? A dry-fired heating element.
Yeah, you get a dry-fired element, and I actually, when I train classes to work in the call center, I show this to them. We'll install a water heater. We'll start filling the water heater up. And when you're around the water heater while it's filling, you can actually hear water rushing into it. Well, and I always trick the class because I hear it and I'm like, tell me when it's full. Because you hear the water coming in,
Right.
and then you hear the water stop, and they're like, it's full. And I go up to it and I show them that, of course, it's not full, because what happens as that water's entering, unless you have several hot water faucets open,
Right.
you trap air in here. And so once the air pressurizes, it stops water from flowing in, and typically stops right about here, right up under the upper heating element.
Right.
And then you have a large pocket full of air.
Okay, and so you're going to dry fire the heating element if you apply power to it.
Yes.
And I think we have an example of a dry fired heating element right here.
Yes, that's an example of a dry fired heating element. Now, if you look at these, you can definitely see a difference. I have a new heating element and I have the dry fired one. The new heating element has a nice zinc coating on it, shiny like a nickel or a dime, very similar. Then you see the dry fired heating element, which is burnt up. It's copper in color because it's burnt off the zinc plating being dry fired, and you just see the metal. That's the metal it's made from. It's copper.
Okay, and so there's an example right there, what we're talking about on the screen. That's an actual dry fire of a heating element. So that's what happens when the element's not submerged in water. So what we have to do is this. You're going to need to start filling the tank up. You're going to open up your hot water faucets, all of them in the home, and let them run free so there's not spitting and sputtering. Get all the air out of the tank until they run free, just steady streams for around 3 minutes. Then we can go ahead and apply the power. Now you tell me you do something totally different. You don't even hook it up until it's filled up.
Yeah, I don't even hook electricity to the water heater until I have it completely full. So when I install an electric water heater, I install it, I pipe it, I fill it full of water, I make sure that I purge the air out of several faucets. And once air kind of stops spurting out, I go the extra mile and allow water to flow out of the faucets, usually for about 3 more minutes. And then once I close everything up, I come back to the heater, I check for leaks.
Okay.
If I have any leaks in my piping, I fix it. But then that's when I actually make the electrical connection to it and turn it on. That way I make sure I don't make any mistakes. I have dry fired elements before.
Yeah.
Just a long time ago, and I didn't know any better.
Yeah, and I'm sure people do that all the time.
It happens all the time. It's not a big deal. The good thing is an element's a cheap part. If you
Right.
do it, it's don't cost a lot of money to fix it.
All right, so you want it to run free without spitting and sputtering for 3 minutes, all the water faucets in the house. And once it runs free, steady stream, then you can go ahead and apply power and start heating water. All right, so kind of moves us to our next segment. So that's a little bit about dry fire and how this water heater works. We're going to talk about some troubleshooting and some common calls, service calls that you might experience. And really, it's 2 of them. You've got 2 most common calls that you're going to experience. One of them is insufficient hot water, and the other is no hot water. And really, the insufficient hot water, you're going to have to do some questioning to the customer about a couple of these, especially both of these, really. Because we have to really know, insufficient hot water to a customer, their expectation may be different than yours. Hot water to me may be really hot, and you may not think it's that hot at all. So we got to find out what they mean by insufficient hot water.
Yeah, we usually want to make sure that what we think matches their definition. When a customer says insufficient hot water, it could mean a couple of different things. One, it could mean that the temperature is just not hot enough.
Right.
And then 2, it could mean that the amount is not hot enough. They're not getting the volume of water or hot water that they expect to get out of a water heater, especially if it's a new installation.
Right, yeah, and customers' expectation on a new water heater, they think that whatever thing, if it's brand new, it's going to give them more than what they had before. That's what they're going to think, no matter what. You could have a 50-gallon tank in here and you put in a 40-gallon tank. Just because it's new, they're thinking they're going to get more hot water out of it because they don't know really how the water heater works. They don't know what the temperature setting was. It could have been an older water heater, been in there for a long time. They could have had the temperature set up higher. Those are things that we need to find out whenever we take a call like that.
Yeah, typically with the lifespan of a water heater, until recently, most of your automatic washing machines and dishwashers required you to have the water heater set to 140 degrees for the dishes to come clean.
Right.
So that was a long time ago when the customer may have adjusted that temperature. They don't remember what they set it to. The water heaters come factory preset at 120, and that's usually what they'll leave it. When the installer installs it, they don't usually take off these panels.
Right.
They install it, and it's good to go. And so that could cause an issue where the customer, says they have insufficient hot water.
Exactly. So now we've got a call. We've determined that it is a water heater issue. So what we're going to have to do is we're going to have to go check the water heater out. So, as a contractor or a service technician going out to a house, we've got to have the right tools when we work on this kind of job. So let's go over the kind of tools that we need to carry on our truck when we're doing service work on electric water heaters.
All right, and I'll show you several tools.
Okay.
First thing you have to have, and this is true if you work on any water heater, is a digital multimeter. This is a digital multimeter from UEI. The thing I like about this digital multimeter is this. It has a clamp-on amp meter, and that makes troubleshooting very easy.
Yes.
But a lot of people don't have clamp-on amp meters. It's kind of a premium feature of a digital multimeter, but I really like it. As long as you pretty much have a digital meter that can test voltage, ohms, or continuity, it'll work.
Okay.
And that's just one tool.
What else you got over there?
I have plenty of tools.
Oh,
in
well,
my bag of tricks.
hand me the digital multimeter because we're going to go ahead. It's actually got a cool feature on here. It's magnetic, so we can keep it on here. We're going to use that in a little bit.
Yeah, it sticks to it. Another thing that I like to carry, and this is just for my own comfort, and it's not a very expensive tool, I like carrying a no-contact voltage finder. What this tells me, it doesn't tell me how much voltage is coming to the appliance.
Right.
It tells me whether or not it has voltage or not.
Okay.
And so I like to verify several times that power is off before I stick my fingers.
They'll see what we're talking about in a moment.
Yes.
But yeah, that does come in handy.
Some other tools that are usually recommended, one is a Phillips head screwdriver. Typically a number 2 Phillips is what you use to work on these water heaters.
Take off the panels.
And that's a simple hand tool usually people already have.
Okay.
A couple of other tools are element wrenches. Usually you can go to any kind of distributor and find something similar to this. This is a element wrench. You usually use a screwdriver. You stick it in, put on the element, stick it in there, and use the screwdriver as a lever to remove the element. These are okay if you don't change a lot of elements or if you don't do this every day.
Right.
These typically, I've had several of them. They came around in my tool bag. They get thrown around. Or if I have an element that's hard to get out because it has a lot of sediment built up, it flares it and it doesn't grip very well. That's just one type. What I usually recommend and what I carry is an 1.5 inch deep well socket on a 1/2 inch ratchet. This is very durable. I can remove a lot of elements with this, even if an element's kind of stuck in the water heater due to corrosion.
Right.
I mean, it's sturdy enough I could put a breaker bar on it and get it loose. I'm not going to flare it. I'm not going to bend it. I've never broken one on a heating element.
Okay.
So, I mean, it's typically something it's a little bit more of an investment, but it's going to last for years.
Yeah, that's what I mean. You can use it for a long time.
Yes.
All right, so those are the type of tools that you're going to need to carry with you. And so now we're going to get back to the water heater. So we've got an insufficient hot water call. And the first thing we're going to have to figure out, like we said in the beginning, is it not, the water's not hot enough, or is it not enough hot water, correct?
Yes, and so we have to ask some probing questions to make a determination. If it's just a situation where the water's not hot enough, we might need to check a couple other things that aren't the water heater. It could be a thermostat adjustment on the water heater if they just had it installed. But we have to ask them by what they mean.
Yes.
You could have a mixing valve set wrong.
And it could be in one area of the house and not the other. I mean, they could have the hot water's fine in the kitchen, but in the upstairs bathroom, we're just not getting enough hot water.
Yeah, every home has a different plumbing system, and so you really have to check some stuff. But insufficient hot water, typically on a water heater that's functioned fine in the past, is most of the time going to be usually a failed lower element. Say you're getting some hot water, but then it runs out fairly quick and it's different from what it did in the past. That usually means the lower element has failed.
Yeah, and it makes sense because you were saying that, you know, most of the work is done in the lower heating element.
Correct.
And if you're just getting not enough hot water, and it failed, that's all that's working would be the upper heating element, and it's only heating the upper 20% of the tank.
Yes.
Correct?
And for this water heater to work, to have any hot water, the upper has to work.
Yeah.
So if you have some hot water, the upper's working. If you're running out of hot water really quick, it's typically something that's failed with the lower portion.
Okay, so it's the lower heating element. So let's go ahead. We've figured out that they're not getting enough hot water. It's not lasting as long as they think it should be. So we're going to go out there and check on the water heater. We've got it in our mind. We're thinking it's that lower heating element. How do I check that?
Well, it's easy to check. Couple things, and I believe there's a screwdriver.
Yeah, we got a screwdriver.
First thing, anytime you work on an appliance, especially an electric water heater, and this is very important, make sure that you disconnect it from power.
Okay.
So either go to your breaker box, find the breaker labeled water heater, and turn it off. Usually if the water heater is not line of sight of the breaker box, you may have a disconnect or a switch you can turn it off. That also. But always make sure you turn off power before servicing the water heater. All right, and since we're insufficient hot water, we know the upper portion is probably working correctly. I'm going to go ahead and go down here to the bottom and kind of show you guys. Pull up my little stool. So after I turn off the breaker, I'm going to remove the access panel on the water heater. So using my Phillips screwdriver, I'm going to remove it. And of course, you see we're missing some insulation, but we've
talked about that. We had to take it out because for TV purposes, you wouldn't have been able to see much if we would have left it in there because it's well insulated. I'll tell you that.
Yes. And like I said, before I stick anything, any tools, anything in there, I always like to make sure power's off, and this is very important. If you don't have a no contact voltage finder, you're going to have to take off the top access panel and check it at the thermostat, which you just always want to make sure it's off. But the important thing about a non-contact voltage finder is you always want to test it against a live source of power, something you know that's turned on, to make sure that it works. You don't want to just trust your life in this or using this tool, and then stick your hand in there and power's on because this didn't go off because the battery's dead.
Yeah, and you've got an outlet over there. You can test it.
And it may have been hard to see, but you could hear it beep. It lights up red, and so I know this is working. So I just stick this in here, and I don't have to touch anything metal. I just have to get it close to it.
And we're just looking for power coming down here. We've already turned it off at the breaker.
Correct.
But we're just checking for power.
I'm just verifying.
Right.
And you can't see it on the screen, but the thermostat covers actually remind you to turn off electrical power before servicing. So there's really no excuse to get shocked or anything. You should always heed to the instructions. And so once that's off, I'm going to stick my hand in here. I'm going to remove this lower thermostat cover. Because it blocks the element, and that opens up where I can see all the parts of the water heater. All right. And so the test for the element's fairly straightforward. I have two wires that go to the lower heating element. I'm going to have to remove the wires from the lower heating element. So power's off.
Power's off.
So it's okay for me to stick a screwdriver in here. So I want to remove the wires from the element to break the circuit. Carefully remove the wires out of the way. All right, and once they're out of the way, using my multimeter, I'm going to set my multimeter to the ohm setting. And a kind of a joke that's been going around for years, and I've told a million times, it never gets old to me, is that the ohm symbol is the omega symbol, which is an upside-down horseshoe. So I'll tell people on the phone, turn it to the upside-down horseshoe, and we'll figure it out.
It's easy to remember. They can see it.
All right, so using my multimeter, I'm going to test the element. Now, for me to do this, I'm going to touch each lead to one of the screws on the element.
And again, we don't want anything but the leads going past this plane here.
Yes. Well, with power off, we can do some different things, but if we were checking for power, yes. So power's off. We're ohming the element. We and we're getting 12.5 ohms on this one. So this is a good element.
Right. We get a good shot of that? Yeah, and what are we looking for on the element? What's the range?
Typically a good heating element, it depends on the wattage and voltage, but typically a good heating element is going to read anywhere from about 9 to 25 ohms.
Okay.
This 4,500 watt element typically is going to read around 12 to 13, and you see we're getting 12.6. And so this is a good heating element.
Okay.
Now what you would typically see on a bad heating element,
Yeah,
if you can
we've got one right
show
here.
me that bad one. If I was to go test this, you'll see that I don't get anything. My meter doesn't change, showing that the element is open, meaning the filament is broken inside the element. So this is a reading you'd get on a bad element, or the numbers may be way off.
Okay. And if the numbers are way off, what is that? That means it's failed?
It means it's bad, but another possibility is this, and this is something a lot of people don't think of. Talked about tools getting beat around in your tool bag. Another possibility is that your multimeter's acting up.
Exactly.
And so what I recommend anytime I'm going to work on a water heater, I typically carry common replacement parts.
Okay.
If I'm working on an electric water heater, I want to make sure I have an element with me. I want to make sure I have thermostats with me. So sometimes if I'm getting a wacky reading from my multimeter, a lot of times what I'll do, I know this element's brand new, I know it's good, I'll check it. I'll pull my meter or my element off the truck that I know is good, check it. If I get a crazy reading on it, and I got a crazy reading on that.
Same reading, yeah.
Yeah. I know something's probably going on with my meter, and that one's may be good.
Okay.
But typically, your most common cause for insufficient hot water is going to be that the lower element has failed. If it's a newer water heater, it could be the temperature set a little bit low. If it's brand new installation, that's usually something a customer is going to complain about pretty early on.
Yeah, and they need to, that's one of the things when you determine what they mean by not enough hot water or insufficient hot water. Do they have not enough, or is it not hot enough? But you know, if you've determined that it isn't enough hot water, then that's whenever you would go and you would do the test that we just did. So we're looking at the lower heating element, and we're going to check and see if that heating element is bad. So that's what we were looking for. 12.5 is what we got, you know, but you can get anywhere between 9 and 25 ohms on a typical heating element. Now, another thing about the heating element, now that's something we need to be carrying on our truck.
Yeah, anytime you work on a water heater, if I'm going to go out, I'm going to carry common replacement parts.
Right.
The good thing about an electric water heater really is that the replacement parts, you're not out of a lot of money, because you got to think, if you're carrying around parts on your truck, you're out money for the parts, right?
Exactly.
Until you do a warranty claim or sell the parts. An electric water heater, its parts aren't very expensive, so it's not that much of an investment. You typically find electric heating elements pretty cheap. You might want to carry around a couple of different common wattages and voltages for your area to make sure you have them. They don't take up a lot of room. Thermostats, it's something a lot of heaters actually take the same exact thermostat.
Okay.
So, I mean, it's good to have them.
And that's another thing, too. The thermostat actually, how we're sensing water temperature is we're sensing it on the tank. We're sensing the tank temperature with that thermostat, aren't we?
Correct.
We've got one over there.
I can show you some examples of some thermostats. This is a lower thermostat on an electric water heater. This actually has a bracket that holds it right up against the tank.
Yes.
The way an electric water heater heats water is this. It has elements that screw into the side of the tank that are completely submerged in the water. So unlike a gas water heater to where we're heating the tank to heat the water, an electric water heater, the heat source is completely submerged in the water.
Yeah, so it's very efficient. I mean, it's whatever it's creating, it's putting in the water.
Yeah, it's putting almost 100% of the heat into the water.
Yeah.
Which puts a lot less stress on our tank because we're not superheating the tank. But for this thermostat to work properly, it has to fit up against the tank. I'll flip this around. You see it has a metal back on it, and it has a little round indention in the back of the thermostat. That's the actual kind of like a probe. It's a bimetal disc.
Right.
Technology that's been around for years and years and years, or how it reads temperature. And so this has to fit flush up against the tank. If it doesn't, it's not going to sense water temperature.
Yeah, and that bracket's there. I mean, if you have to replace that, make sure it is against the tank, because if
Correct.
it's not sensing that temperature, it can overheat the water heater.
Correct. It should be snug against the tank. You shouldn't be able to slide anything more than maybe a business card behind it, and not usually they're going to fit firmly against the tank.
All right, well, that was insufficient hot water. Now we've got another call, the other call that we would be typically taking, which is a no hot water call. And I know with a no hot water call, we still have to do the same kind of thing in the beginning, talking to the customer, because we're going to need to find out if, what they mean by no hot water. I know that sounds silly to say. What do you mean no hot water? I mean, it's cold.
Yeah.
But, I had somebody actually say that. I didn't say, they said they had no hot water. And I was talking to him, and I was like, we couldn't figure it out. We went through everything. I mean, we tested it every way possible. I just couldn't understand what they were meaning. They had no hot water. They actually had no water at all. But to them, they turn on the hot water faucet, they had no hot water.
Yeah, I mean.
So, to customers' points of view are different than, you may be thinking one thing, but they're thinking something so totally different. So we've got to figure out what they mean, no hot water.
Yeah, we always have to make sure our definitions match.
Exactly, because you could have hot water in the kitchen, but not in the bathroom. And, so really talk to the customer and figure out exactly what they mean when it comes to no hot water. So we've determined that it is the water heater. They got a cold tank.
Well, and I'll tell you an easy way to determine that. Because you do want to make sure if you have no hot water that you truly have no hot water.
Exactly.
The easiest way to determine that is to actually go to the water heater and either touch the piping above it to see if it's warm, or touch the relief valve that's screwed into the side of it. And if it's cold, that tells you the whole tank of water is cold.
Right, yeah. If that's always going to be the telltale sign, to feel the T&P valve, because it will be warm if that tank is warm. So we've determined that they have a cold tank. Now we got to go out there and work on it. So what do I do when as a service technician, I'm going to the house? What do I do first?
Well, there's a couple of things I always do first. If it's an electric water here, if they have no hot water, the first thing I check is the breaker in the fuse box.
Okay.
Because if it's turned on, I want to turn it to the off position. Remember, turn off power before removing these panels and servicing the water heater.
Okay.
So if the breaker's on, I want to turn it off. Typically, if the breaker is off, you might want to contact an electrician. Something could be shorted out or something could be going on.
Okay.
But I want to turn the breaker to off.
All right.
I'm going to remove the access panel. And since it's no hot water, I know the upper thermostat comes on first.
Exactly.
I focus all my attention to the upper.
Okay.
And to give you an example of what the insulation usually looks
there's
like,
what
we
it
left
looks
this
like.
one this way. And so using my no contact or non-contact voltage finder, I can just stick this in here after testing it to a live source of power to make sure it works. I can stick it in here. If I had voltage, this thing would squawk at me.
Okay.
If I don't have that, I can use a digital multimeter. You got to be kind of careful doing that, because I'm going to have to kind of move these wires out of the way a bit. I'm going to have to lift this insulation up, that batting
We're
insulation.
going to have to hold this anyway.
Yeah, and usually you could tuck that in there, or Jerry's a great assistant. He can hold it up.
I'll
for
hold
me.
it, yeah. That's what I do best. Or you can use some duct tape, something to
Tape
get
it
it out
to
of
the
the way.
side. That you don't want to fight with it. I have to remove this cover, and so I'm pretty sure power's off, but I still want to proceed with caution. Grab this cover from the bottom of it, remove it, and sometimes they can be stubborn. We get that cover off. And I can use my digital multimeter, set it to the voltage setting, and I can test to make sure power's off. I do that by testing between the two top screws, which is screws 1 and 3. And I can verify power's off, right? So power's off. All right, so once I've checked the breaker, I'm sure power's off, everything's off. There's something I can do.
Okay, what are we doing?
All right, so check the breaker, turn it off. The next thing I want to check is the reset button.
Okay.
You see I have a red button right here, and I can show you on this one. Hold this one up. This has a red button. This button is an ECO, which is an energy cutoff. It's a safety device that trips if the water gets too hot.
Okay, so that if the water gets too hot in the tank, our ECO is going to cut out. Now that's set to what, 170 degrees?
It's 170 degrees on this model of thermostat. They range sometimes, but typically all your newer water heaters is 170 degrees. But
Okay.
if this trips, you're going to have no hot water.
Right.
And so that's why I check that first, because that leads to a different problem.
So if I mean, that's a pretty quick fix. You can just press it and do we just tell them to press the button and hook it all back up and turn it back on and go?
No, you never want to do what I call reset it and run.
Right.
The reason being is because if that button trips, that means the water has become too hot. It's went up to 170 degrees
Yeah.
and tripped that button. That way the water didn't get any hotter than that. So if you was just to simply reset it and leave, you know, you could create a potentially hazardous situation with the water. You know, it could scald someone.
Exactly.
Especially if you don't have mixing valves installed. So you never want to reset it and run.
Okay. All right. So now we've determined that it is the reset. We've clicked it. What's my next move? What's going on? Why did the water get too hot?
Typically, if the water has become too hot, it's one of two reasons. It's either one, a grounded heating element that's either grounded or shorted, or otherwise it could be a stuck thermostat.
Okay.
Meaning that the thermostat was called for heat, it closed contacts in it, the power of the element, and the contacts never opened back up.
Exactly.
It overheated the water, tripped the button.
And what do you mean by a grounded heating element?
A grounding heating element means this. You have an element, this element's copper sheath. It has a filament wire in it, right? Well, this filament wire is isolated like a wire would be in insulation from this sheath.
Okay.
All right? And so what happens over time as an element heats, it cooks sediment onto it, magnesium and calcium
Right.
baked to the element. That causes the surface of the element to overheat. It could put a hole in it. Then what happens, and it doesn't happen a lot, but it can happen, is that piece of filament can come in contact with this sheath, which is grounded, which means that you're completing the circuit.
I got it.
Power can flow, you can draw current, that little piece of filament is going to start heating. The only problem with that is it's heating without thermostatic control.
Okay.
And so you don't have a thermostat to kick it off because it's only heating with half power very slowly, but it's heating with no thermostatic control.
All right. So let's talk about testing for a grounded heating element. Now, you know, can it happen on the upper and the lower? I mean, the lower is probably our workhorse. That can happen first.
Yeah, it's typically always going to happen on the lower. It can happen on the upper if the heater is used a lot, like say it's undersized where it does actually use the upper heating element a lot, but still typically it's mostly going to be on the lower.
Okay, so
But
let's go ahead and test for it.
Yeah, testing for a grounded heating element is fairly simple, and we'll just show them up here on this upper one. All right, so when we're testing for a grounded heating element, that's power off. That's multimeter, it should be set to ohms. I'm going to remove the wires from the element. Carefully move these out of the way. Let's see, I can stick that to it.
right there.
Now my multimeter says OL on it. That means I don't have a path for electricity to flow. If I touch my leads together or short them, it goes to 0.
Okay.
Now when checking for a grounded heating element, if it's grounded, the meter's going to change. Like as you see right there, you see the meter changes.
Gotcha.
If it's not grounded, it's going to be just like it is when I'm holding these leads apart.
Okay.
And so to check for a grounded heating element, I just stick one lead to a screw on the heating element, and the other lead just ground it to the tank.
Yeah.
Or to the thermostat bracket, and my meter should not change.
Okay.
And I want to do that to each screw.
Yeah, because you wouldn't know where it would happen, on
Yes.
which side of the element it happened. So you'll do it to both sides.
Correct. And I know that's kind of hard to see, but yeah, you check both sides of the element. Now, if I was to do that and my meter was to change or display a number, that means the element's grounded. It'll typically need to be replaced.
Okay.
And when you're checking for a grounded heating element over hot water or overly hot water, check both of them. Checking them is the same exact way. Just make sure power's off, remove the wires, but your meter shouldn't change.
Okay, but if it does change, then that's when you would go ahead and replace that heating element.
Correct. You'd want to replace the heating element.
Okay, and if it doesn't change, then the elements are good.
Then the elements are good.
Okay, so what happens if our elements are good?
If the element's good, then we have to kind of look around some more. We have to dig a little deeper.
Okay.
Right? Because it's going to mean that a thermostat is stuck. Now, typically, lower's the workhorse, the lower's going to be the one that sticks. But sometimes, like I said, if it's size, maybe not the best size for the home
Right.
application, it could happen to the upper. So we want to ask if they noticed if the water was overly hot.
Right.
Did the water heater overheat? And if it did they have super hot water just for a short period of time,
Right.
then it went cool? Or did they have a whole tank of scalding hot water, like were they able to take several showers in a row and it was very, very hot? Or were they not even able to get through the first shower?
Yeah, so that's going to tell us which one it is.
Correct.
If they have a little bit of overly hot water, a short amount of overly hot water, then we're going to be looking at our upper thermostat. But if they had a whole tank of it, then we would be looking at the lower thermostat.
Correct.
Okay, so how are we going to check for that? I mean, once we've determined that let's say it's just a little bit.
If it's just a little bit, if we verify that neither element or the elements
Yep.
were not grounded, or the upper element wasn't grounded, in this case, we would just go ahead and change it. There's really not a good way to check the thermostat. So all you can do is eliminate what you can check.
Okay.
And so if a little bit of overly hot water, change the upper thermostat. A lot of overly hot water, change the lower thermostat, as long as the elements, checked fine.
Okay. So how are we going to do? Let's walk through testing for. What about if we have the elements checked good, and what if we have a stuck thermostat? How would we go about testing for that?
Like I said, stuck thermostat, there's really no way you can do it. You just have to verify that the elements are good.
So we would verify that the element is
Yeah.
good on this, and then we would just replace the thermostat.
Correct, just replace the thermostat. Like I said, in most cases, it's always going to be something with the lower portion. So if the elements aren't grounded, if it's overheating, if it's a lot of overly hot water, it's typically going to be the lower thermostat.
Okay, so what if, okay. So our next thing I want to talk about is, what if everything checks out
Well, say,
and we're still not getting,
well, that's just if we have no hot water.
right.
We check the reset and the reset was tripped.
Right.
Say the reset wasn't tripped.
yeah, let's talk about it. Yeah, that's where I'm going. See,
Yeah.
you're good.
I had to bring you back
yeah.
around.
I don't know where I was going with that.
Let's say the reset wasn't tripped,
yeah,
right?
If the reset's not tripped, and we're still, what's going on with that? I mean, you've taken off the upper panel, the reset's not tripped, but we don't have any hot water.
Well, then we're going to have to start checking power,
I
right?
don't know where I was going.
And that's where the testing gets kind of hairy. This is where this gets really important. So power is going to be on. And the rule I'll follow with testing with power that's on is this. Once power is on, our hands, nothing goes in this plane of existence right here but the leads of a test instrument. So my multimeter leads are the only thing to pass through that opening. Now typically the wires would be hooked up and everything like that. You'll also notice on multimeter leads, if you own one, they have stops molded into the leads. Those are for your fingers not to slide down any further than that point. And so if I don't have any hot water, all right, I've checked all this stuff.
Yep.
All that was fine. I'm going to have to turn power back on.
Okay,
all
so
my
our
wires,
reset's not tripped, everything?
all my wires are going to be hooked back in where they go. I'm going to check where I know I should have voltage first. I know if I have a cold tank of water, the upper thermostat's calling for heat, it should be powering the upper element.
Exactly.
So I'm going to check for power at my upper element first.
Okay.
So being careful, making sure nothing but my leads go in here on a stick, one lead on each of the screws on the element.
Okay.
Now, if I get voltage, say I have 240 volts like on this water heater, if I have 240 volts but I don't have any hot water, that typically means the upper element has failed.
So to replace the upper element.
Correct. If I test here and I don't have
it.
power, I'm going to back up a bit.
Okay.
So if I test here, I don't have power, I'm going to test to see between the two top screws to see if I have power coming to the water heater.
So if you have power coming here, and you still don't have power going to your element,
That
then-
means my upper thermostat's typically failed because we've already checked the ECO, we've checked all that stuff. So if the ECO's good, or not tripped in this case, doesn't
Exactly.
necessarily mean it's good. But if I don't have power to the element, but I have power coming to the thermostat and a
Right.
cold tank of water, the upper thermostat's bad.
All right, what if we don't have power coming here?
Now, if I don't have power at the element, I don't have power at the thermostat, I got to kind of back up and check some stuff. And about the only thing I typically recommend checking is power at the junction box, where the water heater's wired to the breaker, right?
Right.
I check my connections there. If my connections are clean and tight and not loose or anything like that, typically that means you have an electrical issue coming to the water heater. It could be an issue with the wiring coming to it or something in the breaker box. That's kind of out of our realm or my realm. I typically recommend to contact an electrician. A breaker could have failed, a wire could have come loose inside the breaker box, something typically you might not want to fiddle around with too much.
So if the reset didn't trip on this unit, we were going to check for power, follow all our safety tips. We're going to check at the heating element. If we don't have power at the heating element, if we do have power at the heating element and it's not working, replace the heating element.
Yes.
If we don't have power at the heating element, we're going to check power coming into the thermostat, into the water heater.
Correct.
If you do have power there, then it could be a thermostat. If you don't have power there, then we're going to check up here coming to the water heater itself.
Correct. And if there's no power there, contact an electrician.
Yeah.
But it's fairly simple. I mean, so typically, most of the time, if your upper element survives installation, you do not draw fire, it's typically something you're not going to have a problem with. Usually the element that's going to fail first after years and years and years of operations typically going to be the bottom.
Your lower heating element.
Just because of usage, because it's the workhorse.
Yeah, and if the water heater is sized properly, then that's probably going to do most of the work. But it could happen. You could have instances where it's working more than the other in some undersized situations where you're using all the hot water in the tank and the upper heating element starts to come on more often. But you'd get a lot of calls on insufficient hot water probably in those cases, or not having enough hot water if you're undersized. Well, what we want to do now is see if we have any questions about anything that we've covered here. We can go, I guess we'll go back over to the desk and see if we've got any questions. While we're looking, okay. Doesn't look like we have any questions. If you do have questions, anything about what we've covered here today, you can email us at university
hotwater.com.
At hotwater.com, correct? Yes, that's what it is. Golly, I couldn't remember what it was.
Your brain fried today,
I don't
Jerry.
know what I was thinking. But what I want you to do right now is you're on the website. I'm pretty sure that's where you're at. You're watching this video on our new website. It's our our university website. Take a look at that website. We've got different shows that we've done in the past. You can kind of browse through them, see all the different shows we've done. If you're interested in training, it's perfect because it shows you all the different training options that we have available. Live video training, hands-on training. You can even register for classes on that website, but that's university.hotwater.com. And check it out and tell us what you think.
And I believe some of the video courses, it shows the video, you can actually take a test.
I think there's a certification course on there, especially on like residential electric and gas course. So take a look and tell us what you think. And it's a pretty cool website. We're very proud of it. But it's got a lot of stuff on there, especially the videos. A lot of videos that we've done in the past and recent videos. But check it out and tell us what you think. But that about does it for today.
That's it.
For Kenneth Ezell, I'm Jerry Winslet. We'll see you next time.